In the mid-20th century, Russia embraced the promise of nuclear power. As the world was caught up in the throes of the Cold War, a new energy source was emerging, one that held the potential to revolutionize power generation. It was during this time that Russia, then a part of the Soviet Union, took a decisive step into the future by harnessing the formidable power of the atom. In the year 1954, the first nuclear power plant in Russia was commissioned in the city of Obninsk. This was an impressive feat, considering that the concept of nuclear power was still in its infancy. The Obninsk plant marked the beginning of a new era in energy production, and it set Russia on a path of rapid growth and development in the field of nuclear power. The ensuing years saw Russia making strides in nuclear technology. Power plants sprang up across the vast expanse of the country, each one a testament to the nation's commitment to this new form of energy. It was a time of progress, of pushing boundaries, and of embracing the unknown. The nuclear power sector in Russia was not just about power generation. It was a symbol of the country's technological prowess, a beacon of scientific achievement that shone brightly against the backdrop of the Cold War. Each new power plant that was built, each new milestone that was achieved, served to reinforce Russia's position as a global leader in nuclear technology. As we moved into the 1980s, the landscape of Russia was dotted with nuclear power plants. These towering structures, with their distinctive cooling towers, had become an integral part of the country's identity. They represented the promise of unlimited power, the dream of a future fueled by the atom. But with great power comes great responsibility, and as Russia was about to learn, the path to nuclear power was not without its perils. The promise of nuclear power was intoxicating, but it also carried with it a potent risk. A risk that would soon cast a long and ominous shadow over the country. By the 1980s, Russia had become a world leader in nuclear power generation. But the journey was far from over, and the greatest challenge was yet to come. Located near the town of Pripyat, the Chernobyl power plant was a symbol of Soviet technological prowess. This colossal structure, nestled in the heart of Ukraine, was more than just a power plant. It was a testament to the might of human innovation, housing 4 massive reactors that hummed with the promise of boundless energy. The plant sat only a stone's throw away from Pripyat, a town that bustled with over 49,000 residents. Its very existence was intertwined with the plant, with most of its population working there. Beyond Pripyat, other nearby towns like Chernobyl and Yarniv also thrived, their lives echoing the rhythm of the power plant's heartbeat. The Chernobyl power plant, with its 4 reactors, was not just a provider of electricity. It was a beacon of progress, a symbol of how far humanity had come. But on April 26, 1986, everything changed. A routine safety test went horribly wrong, leading to one of the worst nuclear accidents in history. This haunting statement takes us back to the night of April 26, 1986, at the Chernobyl nuclear power plant in the Soviet Union, now modern-day Ukraine. On that fateful night, reactor number 4 was slated for a routine safety test. The plan was to simulate a power outage to test the plant's ability to cool the reactor cores in the event of a loss of power. However, this seemingly straightforward test was laden with a series of missteps and oversights that would culminate in a catastrophic disaster. Due to the test's delay, the inexperienced night shift was left to manage the process. As the test began, a reduction in reactor power led to an unexpected drop. The operators attempted to increase power levels, but in doing so, they inadvertently created a highly volatile condition, an excess of voids or steam bubbles in the reactor's coolant. This change made the nuclear reaction difficult to control. In the early hours of April 26th, the operators proceeded with the safety test, unaware of the impending danger. Suddenly, a power surge occurred. The operators tried to initiate an emergency shutdown, but it was too late. The excess steam caused a massive explosion that blew the 1,000-ton roof off the reactor, releasing a cloud of radioactive material into the atmosphere. The immediate impact of the explosion was devastating. 2 plant workers died on the night of the explosion, and 28 firefighters and plant workers died within the next few weeks due to acute radiation sickness. But the damage didn't stop there. The explosion released an estimated 5% of the reactor core's radioactive material into the environment. This radioactive cloud was carried by the wind, spreading contamination across vast swathes of Europe. The nearby town of Pripyat, with a population of around 50,000, was not immediately evacuated. It wasn't until 36 hours later that officials ordered an evacuation, by which time many residents had been exposed to high levels of radiation. In the ensuing chaos, a graphite fire raged for 10 days, further spreading radioactive material. It took the concerted efforts of hundreds of thousands of liquidators, firefighters, soldiers, miners, and volunteers to contain the situation. The Chernobyl disaster was not just a tragic accident. It was a stark reminder of the potential dangers of nuclear power when not properly managed. It highlighted the need for stringent safety measures, transparency, and comprehensive training for all personnel involved in nuclear power generation. The effects of the disaster were far-reaching and long-lasting. The incident at Chernobyl left an indelible mark on the world, shaping our perspective on nuclear power, influencing policy changes, and leaving a region forever scarred by the disaster's aftermath. The Chernobyl story continues to unfold, a testament to the enduring impact of this catastrophic event. The cleanup efforts at Chernobyl were an unprecedented challenge. The immediate aftermath of the disaster saw an army of workers, known as liquidators, mobilized to manage the crisis. Their mission was twofold: to contain the radiation and initiate the cleanup of the site. In the face of an invisible and deadly enemy, these brave individuals embarked on a perilous journey. They constructed a colossal structure known as the sarcophagus, a mammoth shell of concrete and steel, designed to encase the damaged reactor and halt the spread of radiation. This Herculean task was fraught with danger, yet it was accomplished in an astonishingly short 6 months, a testament to human resilience and ingenuity. Parallel to these containment efforts was the evacuation of Pripyat, the city closest to the Chernobyl plant. A once bustling community of nearly 50,000 people, Pripyat was transformed overnight into a ghost town. The swift and orderly evacuation was a necessary measure to protect the inhabitants from the perilous levels of radiation. In the wake of these evacuations, an exclusion zone was established. A stark reminder of the disaster, this area, spanning roughly 2,600 square kilometers, remains largely uninhabited by humans to this day. It serves as a buffer, a safeguard, preventing the potential spread of radiation to surrounding regions. However, the cleanup and containment efforts at Chernobyl were far from a one-time endeavor. Even today, over 3 decades later, work continues. The original sarcophagus, now aged and weathered, was replaced in 2016 with a new, more durable structure known as the New Safe Confinement. This vast arch, large enough to house the Statue of Liberty, was designed to last for a century, ensuring the continued containment of the Chernobyl site. Despite the monumental efforts, the shadow of Chernobyl still looms large. The disaster serves as a stark reminder of the potential consequences of nuclear power when not properly managed, and underscores the importance of stringent safety protocols and regulations in the realm of nuclear energy. The exclusion zone became an unintended wildlife sanctuary. The Chernobyl disaster initially had devastating effects on the local wildlife. High radiation levels led to a significant decrease in animal populations due to mutations, illnesses, and deaths. Birds were especially affected, with many experiencing reduced brain size and altered feather coloration. Invertebrates too saw a decline in numbers, with species such as spiders and butterflies being hit hard. However, as time passed, a surprising phenomenon occurred. In the absence of human interference, the exclusion zone started to see a resurgence in its wildlife populations. Animals that were once rare in the region, like the European bison and Przewalski's horses, began to increase in numbers, roaming freely in the deserted lands. Packs of wolves started to thrive, with their population density even exceeding that in some renowned nature reserves. Recent research findings have been nothing short of fascinating. In a study published in the journal Current Biology, researchers found that some birds in the exclusion zone have adapted to the high radiation levels. These birds exhibit higher levels of antioxidants and less genetic damage compared to their counterparts in less contaminated areas. Ongoing studies are exploring the long-term effects of radiation on wildlife. These include investigations into the genetic changes occurring in the animals and their potential to evolve radiation resistance. These studies could provide invaluable insights into how wildlife adapts to such extreme conditions. It's important to note, though, that while wildlife seems to be thriving, the exclusion zone is by no means a wildlife paradise. The animals are still exposed to high radiation levels, which could potentially have negative effects on their health and longevity. However, their presence and the fact that they're breeding suggests that they're coping with the conditions better than expected. In the face of disaster, nature found a way to adapt and thrive. This unexpected turn of events serves as a testament to the resilience of nature, even in the face of human-induced catastrophes. Despite the tragedy of Chernobyl, nuclear power remains a vital part of the world's energy mix. Today, nuclear energy contributes about 10% to the global electricity supply, with over 400 reactors operating in about 30 countries around the world. In Russia, the birthplace of the Chernobyl disaster, the reliance on nuclear power is even more pronounced. Nearly a fifth of the country's electricity is generated from nuclear power, with close to 40 operational reactors. This makes Russia one of the top 5 nuclear energy producers globally, alongside the United States, France, China, and Japan. The Chernobyl disaster served as a wake-up call, leading to a global reassessment of nuclear safety. In the aftermath, countries worldwide tightened their safety measures and regulations. The International Atomic Energy Agency, or IAEA, took the lead, implementing a series of measures aimed at improving nuclear safety. These included stress tests to assess the ability of nuclear plants to withstand extreme events, and the establishment of the World Association of Nuclear Operators, which promotes information sharing and peer reviews to enhance nuclear safety. In addition, technological advancements have led to the development of safer and more efficient reactor designs. These so-called Generation 3 and Generation 4 reactors are designed to be inherently safe, meaning they rely on passive safety features that require no operator actions or electronic feedback to shut down safely in the case of a malfunction. Yet despite these advancements, the shadow of Chernobyl still looms large. The disaster serves as a stark reminder of the potential dangers of nuclear power if not properly managed. It underscores the need for continuous vigilance, strict regulation, and rigorous safety protocols. The lessons of Chernobyl have shaped the nuclear industry, making it safer and more reliable. While the disaster was a dark chapter in the history of nuclear power, it has also been a catalyst for positive change, driving the industry towards a safer and more sustainable future. As we face the challenge of climate change, nuclear power offers a low-carbon energy solution. But what does the future hold for this powerful yet controversial form of energy? Let's delve into the world of atoms and neutrons to find out. The promise of nuclear power lies in its extraordinary energy density. A small amount of uranium, the fuel used in most nuclear reactors, contains around 1,000,000 times the energy of an equivalent amount of coal. This means that nuclear power plants can generate huge amounts of electricity from a relatively small amount of fuel, all while producing virtually no greenhouse gas emissions. This is an important point. As we strive to reduce our carbon footprint, we need energy solutions that can meet our growing demands without exacerbating the climate crisis. Nuclear power ticks this box. It's a steady, reliable source of power that can operate around the clock, regardless of weather conditions. And unlike fossil fuels, it doesn't pump vast amounts of carbon dioxide into the atmosphere. But the potential of nuclear power extends beyond its low emissions. Ongoing research in nuclear technology is driving advancements that could revolutionize the way we generate electricity. For instance, fourth-generation nuclear reactors, which are currently under development, promise to be safer and more efficient than their predecessors. They're designed to produce less waste, have a lower risk of meltdown, and even use spent fuel from older reactors, thereby helping to solve the problem of nuclear waste disposal. There's also the tantalizing prospect of fusion power. Unlike the fission process used in today's reactors, which splits atoms apart, fusion combines them together, releasing energy in the process. It's the same process that powers the sun and stars. If we can harness it on Earth, it could provide us with a virtually limitless, clean energy source. Efforts to make fusion power a reality are still in the experimental stages, but the potential rewards are enormous. Of course, these advancements won't come without challenges. Nuclear power has inherent risks, as the Chernobyl disaster starkly reminded us. However, the industry has learned valuable lessons from past mistakes. Today's reactors are built with multiple layers of safety systems, and the international community has put stringent regulations in place to ensure nuclear power is used responsibly. In the end, the future of nuclear power will likely be shaped by a combination of technological innovation, policy decisions, and public perception. It's a future that holds great promise, but also requires careful navigation. From the ashes of Chernobyl, a new vision for nuclear power emerges, one that combines safety with sustainability. Perhaps in the not-too-distant future we'll see a world powered not by burning the remnants of ancient life, but by mastering the very force that lights up the cosmos.